So I actually made a mistake while recording the second part. So I'm going to re-record it. Yeah, instead of calling the constructor of the B class, I accidentally called this A method because that looked like the constructor. But yeah, we're going to try this again. So the first thing we're doing is creating this object of class A, of type A, and we're passing in the parameter 4. So how I draw objects is I just draw a circle with the type of the object, and then I slowly fill in the parameters, the instance attributes. So this init method is called, and the A that's passed into it is 4. And then we say f is equal to self.a. So then we have this variable f, local variable, only bound in the init frame, and that points to self.a. So self.a is not this letter A, right? Because we haven't bound self.a yet. So this instance actually has nothing. When I look in this circle, I don't have any instance attributes. So I actually have to get the A from the class. So this is going to be, f is going to be pointing to this A in the class, this A method. Then we assign self.a and say that's A but sliced from 1. So that's going to keep only indexes 1, 2, and 3 from this 4. So self.a will just be this 4 but without the f. Self.b is just going to be 2. And then finally we're going to call this function f on a. So that means we're going to call this a function on the variable that stores the value 4, and that's going to be our b. Okay. And then we're going to print a list whose first element is this b, so that's just 4, and whose second element is the type of self. So the type of self is a dot b. So it's the class a dot b. And if I just wrote a dot b, then we'll only look in the class. We're not gonna, this is not associated with any particular instance, so that's just gonna be 1. Now I'm not quite done, because every time you enter something into the interpreter and it evaluates to a non-null value, well, then we have to display that. And how we do that is, what the interpreter does is calls, or essentially does print of repr of whatever object is evaluated. So for example, if I just enter say 5, then the repr of 5 is just the string quote 5. We print that and we just get 5. So for an object, which is a little more complicated, it's going to evaluate to this object in the circle right here. And, oh, I don't know why I erased that. Let's put that back. Okay. So we're going to print the repr. So the repr is right here. The repr returns stir of self.a. So self.a is our. The stir of a string is just that string. And the repr returns this string. So it returns our. And now what we want to do, we have this part, the repr of the object. My pen stopped working. That's weird. Give me a second. Okay, there we go. Sorry about that. So we're going to print the repr of the object. So we're going to print the quote hour, and that'll just display the word hour. Okay. So the next part, we're going to construct a B object. So let's get rid of some of this stuff that we don't need. Actually, we don't need pretty much any of it, except remember this print of repr of object. So we make this B object. And this B doesn't have an init, so we're going to call the init an A. The parameter A is just 5. F is bound to the same A function. And self.a is bound to ive. So That's the same thing as before. We just remove the first letter. So self.a is I've, self.b is 2, and we call f on a. So this same function is called on a, which is 5. Now we still print a list whose first element is b, so let's see. B is going to be this variable right here. So I believe that should be 5. And let me just write this self.b here. Oh, I messed up a little. This f is not pointing to self.a. It is pointing to self.a, but self is a b object. So I should have been more careful when I was looking that up. B, for the b object, we'll look, and there wouldn't be a self.a in the b object yet because we haven't put one there. So then we'll look in the b class. Sorry about that. So then this function f is going to call class a dot a on its own self, and then self.b. Now self.b is 2 now. So this is a 2. Okay, so we're going to print a list whose first element is 2, and whose second element is type of self.b. So type of self is just the class b. So, and then we get the variable b from the class b, so that's just 3. Now we're not completely done. The last thing we have to do is the same as last time. We have to actually print the repr of this b of 5 object. So the repr of this object. And the b class doesn't have a repr, so we go to the a class. And that returns the stir of self.a. So that'll return, quote, I've. When we print that, that'll just become IVE. All right. Yeah, so let's erase all of this now. I believe it has nothing to do with the rest of the stuff. Oh wait, don't want to erase the answers. And let's try the next one. I actually don't believe I got that on when I took this exam, but here's hoping I'm better at 61A than I was in the past. Okay, so we have this function f, which is a lambda function that takes in 2 parameters, g and h. So f is bound to a func lambda that takes in g and h. All right, and its parent is just the global frame. G is the result of calling f on this other lambda and pow. So let's open a frame. F1 is just going to be f parent equals global, whose g is this lambda half, whose parent is also global, and then this variable h, which is pow. Pow is just a function. It's the power function. Then this function f returns a lambda, so return value is a func lambda that takes in p and q, and its parent is this frame, f1, because that's where it was made. All right? So g is now bound to that lambda function. And we're calling this on 3, 5. So we're calling this, we're going to open one more frame. Let's move some things. Okay, I hope that isn't really necessary. And then we know G is bound to this. One second, sorry, my pencil stopped working again. Not sure why. Okay. Yeah, it's probably running out of battery, but we'll try to stretch it. Okay, so G still points to this function, but I wanted to move it away for some space. Okay, so then we create F2, and that's going to be this lambda that takes P and Q, and its parent is F1. It returns the result of, okay, let's just write what P and Q are. P is 3, and Q is 5. It returns the result of calling H on G of Q and P. So that means we first evaluate the operator, which is H, okay? Then we evaluate the operands, G of Q and P. Okay, and what's G of Q? So G of Q, well, what's G? We don't have a G in our frame F2, so we look it up in F1, and we have this lambda half. That basically just halves something. So we probably don't even need to open the frame. Q will just become, G of Q is just going to be half of Q. So that'll just be 2. Alright, and P is just 3. So we just want to call H on 2 and 3. And H is found in, it's not in F2, so we look in its parent. And in F1 we have this H, which is this POW function. So all we're doing is calling the return value is POW of 2, 3, which is 8. Yeah, I guess I should have drawn a better environment diagram on my actual exam, but I'm glad I got it this time. Hope you found it helpful.